My dear friends, welcome back to B Spice. So, in this session, we'll talk about split range control. Hope you are aware that we have been, discussing this controls actually during the last few sessions. The first one was PID, second one was cascade, third one was feed forward. Then the latest today, what we have uploaded is cascade combined with feed forward. Okay. So now this one is a split range control. Okay, friends. So basically, as you can see here, this is your fuel tank and this is your PV, right? Pressure transmitter. And that is getting splitted into two actually. One for the nitrogen valve and one for the vent valve. Okay. This is how it's going to be. The split range is going to be implemented. We will see the details. Okay. So the agenda is we'll talk about the split range outline, okay, as usual. Then we'll discuss about how to configure the split range using Yokogawa DCS, typical example. And also, inside the split loop, actually, we need to do some settings, actually, right? So that is also I'm going to highlight. Just typical example, very short and sweet. Okay, friends, let's move on. See, in split range control loop, one controller is used to manipulate two final control element. Got it, friends? In split range control loop, one controller, okay, is manipulated to manipulate two final control element. These are the final control element. As simple as that. Okay. Consider a process where a fuel tank pressure is maintained by nitrogen and the vent valves. Because many of our YouTube friends they have explained in a different example, so I don't want to repeat. Actually, I want to give something new for you. That's why I've taken this different example. Okay, so the PC is the pressure controller, PID controller. Okay, this is your PID controller with direct action. Okay, so PV1 and PV2 are nitrogen inlet and vent valve respectively. Okay, friends. PV1 and PV2 or the nitrogen inlet and vent valve respectively. Okay. So when the PC output this increases, that is pressure is more. Okay. And the PC output increases, pressure is more, the nitrogen valve to be closed. Okay. And the vent valve to open. Okay. And pressure inside this fuel tank is increased, nitrogen valve to be closed and this vent to open and vice versa. Okay. So that is the concept here. Okay. Now I am going to explain with the help of this Yokogawa. Okay. As usual, if you know, right, see this configuration, we need to go to the system project view, right? You can see here the project view, system view, all these project, all these are there, right? Batch, common, FCS, all these there. So here you need to go to the node actually. FCS, if you expand the FCS, you will have a node. And in the node, you can, select, you need to configure this input. Okay, this is your input. Okay, pressure. Then we have two output, right? This one and this one. Yes, this is the two output. And friends, just to take note here, this is a typical example I have given. We need to customize this. If your output one is controlling from 4 to 20, 4 to 12, then you need to modify this. Then the second one, 12 to 20 amps means you need to modify this. Also the action also you need to modify, whether it's a direct or indirect, reverse. Okay, that one I'm going to explain in the setting in the next slide. Don't get confused. Okay, so now this is your node. Okay, you are done with the node. Then after that, you have to go to the function block and go to the drawing builder. Okay, when you go to the drawing builder, if you click here, you will see all these, MLD, MLD block, PID block, all these will be there. Okay, so you have to just drag and drop. From this, you have to drag and drop. I hope this is clear. Okay, so you may have a doubt actually. What is this MLD and all, right? See, MLD is the one we are going to use it. You can see here this MLD. So MLD is nothing but it's applied to output manipulated to manipulate the output value. Okay, to operate final control element. So that is the MLD. Actually, call it as a manual loader blocker to output the to manipulate the output value. Okay, so that is the point. See here, maybe we can have a one-to-one comparison here. See, you can see here the PT, right? This is your PT. Okay, friends. So this is your PID controller, right? So this is your PID controller, right? This out is going to set as a splitter, right? This out is going to as a set. This is your splitter. Okay. So this out is going to going as a set to the split range controller. Okay, a loop, right? Then from here you can see here the splitter. One of the output is going to one manual loader. So now you can see here this is going to the nitrogen valve, and another output is going to the another manual loader, that is the vent valve. Okay, so this is how we need to configure. I hope this is clear. Okay, right, friends. Now we'll see what is to be set inside the setting. This is a typical example. For example, my PC output range 0 to 45%. So if we set that 0 to 45%, can you see here? This is your MV1. Okay, MV1 0, minimum is 0 and high is 0 to 45. So this is my MV1. So the PV1 operates from 100% to 0%, because here reverse, because this is going to close, right? Yeah, this is going to close, right? That is why it's a reverse. Okay. Then the PC output range 55. You can see here 55 to 100%. Then in that case, the PV2 operates from 0 to 100%. That is a direct actually. So I hope this is clear. Just to add on, don't get confused with this PV and MV, because here we talk about PV, right? And here we are talk about MV, right? So hope you're aware what is PV and MV, right? So if it is not clear, I will explain. See, basically, PV is the process variable which we measure, friends. Okay, MV is the variable we manipulate to control the processor. Okay, for example, PV represent the measured variable in a process. So what is that? It is basically the actual value we measure during the processor. Example of process variable like pressure, temperature, all these. Okay. For example, just for example, if you are controlling the temperature of the fluid in a tank, okay, the temperature of that fluid will be the PV. Okay, so the PV is transmitted from the sensor to the controller and providing a real-time information about the process rate. That is the PV. So what is MV? Here the MV is the variable that controller actively manipulates to influence the processor. For example, it's a parameter we adjust to achieve the desired outcome of the for the PV. Example of manipulated variable include the position of a valve. In our example, the previous example, the position of the valve. Okay, so basically the controller calculates how much MV needs to change, meaning in our case how much the valve open to need to open or close. Okay, based on the difference between the PV and the set point. I hope this is clear, PV and MV. So again to repeat, PV is the process variable we measure and MV is the variable we manipulate to control the process. Okay, friends. So this is how we need to configure, friends. You can see here the MV1 direction is reverse. Okay, here, right? So MV2 output direction is direct here. Okay, that's it, friends. This is the simple example of a split range. Okay. Thanks for your time. And if you like this video, you can show your support by pressing the thumbs up button. And if possible, subscribe and share with your friends. Okay. See you soon in the next video, which will talk about the ratio control. Okay. Thank you. Take care. Bye-bye.